Operators perform an action on one or more values and return the result of the operation. As a general-purpose programming language, C# has a rich set of operators that support almost everything from basic math to complex logic operations to low-level bit manipulations. So what I'm going to do now is explore many of the most common operators that you'll be able to make use of in your own code. Now, keep in mind that C# is backed by all the features of the .NET framework. If you can't find a built-in C# operator that does what you need in a specific scenario, there's a reasonable chance that there's a class with a method in the framework that does what you need. For example, the system.math class provides a rich set of mathematical functions that go well beyond the ability of operators. All right, so let's start out by talking about the arithmetic operators. So here's a list of the most common C# operators that you can use to perform basic arithmetic on one or two variables. The type column indicates whether the operator works on one value, which are unary operators, or two, which are binary operators. There's also a ternary operator that operates on three values, which you'll learn about when we explore branching in C#. Now you can string together the binary operators to, for example, add 10 values in a single expression, a plus b plus c plus d plus e, and so forth. Okay, so you have addition, subtraction, multiplication, division, modulus, increment, and decrement. I'll explore these in some code samples. Here's some code that shows how you can use the different arithmetic operators. So I start out by declaring two variables. One is total amount, which is the number that I'm going to be operating on, essentially, and then a double result that is going to contain the result of the operation. All right, so I start out by displaying what total amount is to start with, and then I take that total amount and add $100 to it. Just use the plus sign, very straightforward, and the result contains the result of that operation. So 100 plus 100 is 200, so this should display 200. And then I'm going to take this amount and subtract 50 from it. Now notice that I'm not changing the value in total amount in these operations so far. So this is once again starting with 100, and it's subtracting 50, so this should display 50. Here I'm multiplying by 6. Here I'm dividing by 17. Here I'm taking the modulus of 17. So this is going to be the remainder of dividing total amount by 17. And then I can do the same thing, dividing by 17.5, what the result is. All right, now at this point I'm going to go ahead and run this code so I can run through and show you what the results are. So I'm going to select F, and I'll move this down out of the way. Okay, so you can see that total amount addition is 200. Subtracting 50 from 100 is 50. Hopefully these all look right. 100 by 6 is 600, so that proves that C# can actually do math. That's always a good thing. Dividing by 17 is 5.88, so forth. And then the remainder of dividing by 17 is 15. Dividing by 17.5, the remainder is 12.5. Dividing by a different amount, so I have a different remainder. And then the last two here is the increment and decrement operator. So you can see incrementing total amount is 101, and decrementing total amount is 100. Now, these operators are unary operators, so they operate on the value itself, this total amount value. So of all these operations that I've shown so far, these are the only two that actually change the value directly that's contained within total amount. Okay, so let me stop that and come back and look at the code. And so for these last two, here's how that works. So I'm using the unary operator, and it's going to increment total amount by 1, and then assign that result to the result variable, and then display it. Now, total amount at this point actually contains 100. So I started out, 101. It started out as 100. I increment it, and now total amount itself is equal to 101. And then here, it's currently 101. I execute this decrement operator on it, And 100 is saved to result, and that's why it printed out that the total amount is now 100. It's back to 100. Now, a couple things to note about this is that, first of all, C# does not define an operator to raise one number to the power of another. So what you need to do is use the POW method, P-O-W method, of the math class instead. So you can use math.pow, pass in x and y, and then it'll return the value of x raised to the value of y. So that's a little bit weird. A lot of other general purpose programming languages do have an operator that you can use to increment values. And most common it's the caret operator, the little angled hat sort of operator. All right, so now more about this increment and decrement operator, particularly their unary natures. So both of these operators cause different behaviors depending on whether you attach them to the value as a prefix or as a suffix. They operate directly on the value of the variable, as I pointed out, and the results can be rather confusing if you use them improperly. Because what happens is that if you apply the operator as a prefix, that operation, increment or decrement, is going to apply to the variable before the value is evaluated and assigned to a variable or used in an expression, whatever the context is that you're using it. So because I used it as a prefix here, total amount is going to be incremented before the assignment takes place. If I had used it as a suffix, put it right over here at the end of the name, then total amount, the current value of total amount, would have been assigned to result. That would have been 100 at this point, because at this point I haven't changed the value. And then total amount would be incremented. So result gets 100, but then total amount has 101. And then if I had used total amount here and used the decrement operator at the end as a suffix, then it would have assigned 101, because that's the current amount of it, current value of total amount, assign that to result, and then decrement it. So in this kind of scenario, in this kind of code that I wrote here, generally you're going to want to use a prefix, but it really depends on what your intention is. And there's lots of scenarios where you can use both. Okay, so here's a method that explores a little bit more about how all this works. All right, so once again, I'm going to run this so we can see the results and follow along. Now I'm going to execute G, and I'll move that kind of down out of the way there. Okay, so I'm declaring amount, setting it equal to 100. And now, in this expression that I'm using within WriteLine, I'm using it as a prefix. So this expression is going to increment amount before it's displayed. And so that's why it says amount equals 101. And now amount is equal to 101. Now I use this twice because this is going to display the result of this expression, and then this is going to display the amount after that expression is evaluated. Okay, so it reads amount, increments it before it displays it, amount becomes 101, and after this expression is displayed, amount is 101, and that's why it says 101 and 101. Okay, so keep in mind that amount is now 101. Now, in this expression, in this WriteLine method, I'm going to use this expression here that uses it as a suffix. So now, this is going to display, it's going to evaluate the expression for the amount as it currently is, which is 101, which is why 101 is displayed there. And then after it's used in this expression, in this case passed to the string, using string interpolation within the WriteLine method, it's now going to be 102. And that's why this says 102. Okay, so now be sure that you understand what's going on there. These are two different expressions. This is evaluating the expression, the current value, and then incrementing it. And then this, after that previous expression is evaluated, is displaying the resulting amount. All right, same thing for the decrement. Amount, as we can see here, is 102. I'm going to decrement it before I display it, so now it's 101. and then display the amount. And once again, it's 101 as a result of this expression being evaluated. And then similarly here, it's going to read the value of amount. So that's why it says 101 there, because it's still 101 from there. And then it's going to decrement it, which is why now when this expression is evaluated, it's now back to 100. So this can be kind of confusing if you're not used to increment and decrement operators. Not all languages work like this. All of the languages derived from C do perform like this. So you may have encountered this in other code and other languages that you may have learned. But really the moral of the story is to be careful how you use the increment and decrement operators. Most of the time, you're probably going to prepend the operators to perform the operation before using the value in the expression, in the assignment expression, whatever you're doing with that variable. But there are times where being able to perform the operation after using the value is quite useful. But if you're not careful, you can introduce subtle, hard-to-find bugs in your code. So be careful with it. But most importantly, make sure that you understand the differences in that behavior, particularly how the prepend and postpend, or prefix and suffix, versions of the operators work and affect the variable. And keep in mind that it's a unary variable, so it's acting on the current value in that variable. No other variables, literal values, or anything else are involved whatsoever. Okay, so let me get rid of this again and start talking about string operators. You can use the plus operator to concatenate or add two strings together. And that produces a new string. So here's some code that adds three strings together. It shows how you can string operators together. So I have author1 equals Don, author2 equals Carol, others equal their dogs. So just three strings that I want to concatenate together. And then I have this expression that concatenates the value of author1 with space and space, author2, space and space, and others say hello. And then I display that greeting. So altogether, I have four strings here. The three strings that I'm concatenating and this fourth string in the greeting variable. So when I run this code, I'll press F5. And I'll press H, and you can see Don and Carol and their dogs say hello. We have sled dogs. We live in Fairbanks, Alaska, so I think about dogs a lot. All right, so very simple, sort of an example. That's how you can concatenate multiple strings together. Now, one caution about this is that adding two strings together creates a new string, even if you've not created a new variable. So for example, instead of creating a new variable here, string greeting, I could have assigned the value of this concatenation to this others variable. And that tends to be a fairly inefficient process because it's creating a new string variable in memory and then replacing the existing string in others with that value. Again, I didn't do that here, but you have to be careful. And in that case, if you're doing a lot of string concatenations, particularly in loops, you'll probably want to use the string builder class instead. But I'm not going to talk about that class right here. Now I want to talk about the binary assignment operators. You know, quite frankly, I think these are some of the coolest operators available in C#. All right, so the idea here is that there's a very common pattern when you're using any of the C# binary operators. Is something like this code. You're declaring a variable, int total amount, setting it equal to 100, and then you're performing an operation in order to change the value of that variable. So here I'm setting total amount using an assignment expression and setting the value to total amount plus 50. So I'm not assigning the result of that addition to a different variable. I'm assigning it to the same variable that I'm using within the operation. So the result, of course, here is 150. So very straightforward. So this is so common an operation with some operators that C# provides binary assignment operators that simplify the code that you need to write. And here's a few of the different binary assignment operators. You have addition plus equals, so it adds two numbers or converts a negative number into a positive number. Minus equals, which is subtract two numbers or convert a positive number into a negative number. Times equal, or multiply equal, you multiply two numbers. And divide equal, you divide two numbers. All right, so using one of these operators, instead of that code at the top of the slide, I could write that. I can just say total amount plus equals 50. So this will take the current value of total amount, add 50 to it, and then assign the result of that addition to the total amount variable. So if I start out with total amount equal to 100, then the result is, just like the previous statement, total amount is going to end up as 150. Here's some example code that shows how you can use these operators. All right, I'm going to go ahead and run this one more time. And I will execute I this time. And there are the results. All right, so I'm starting out by declaring a total amount, setting it equal to 100. And then I'm adding 50 to it. So this is a typical use of the binary addition operator. Total amount plus 50 equals 150. I display that result, and we can see that once again, C# can add. Always a good thing. And so now I'm going to do the exact same operation, but using the binary assignment operator. So I'm going to add 50 to the current amount, which is 150. 150 plus 50 is 200. Display that amount, and that's right there. And then I'm going to use the subtraction binary assignment operator. I'm going to subtract 50 from the current value of total amount. It's currently 200, so it results in 150. And the multiplication, 150 times 3 is 450. And then divide by 3 gives me 150 back. So you can see where this is a very nice, compact syntax. It's not saving you a whole lot of typing from this statement here, but there's a lot of situations where it's just a lot cleaner. It's a lot easier to read. You can scan down a number of operations if you're reading code and see exactly what's going on. It's very clear. It's a really nice improvement to the language. But the bottom line here is that the binary assignment operators really are just a way to save what potentially can be a lot of keystrokes for this very common kind of an operation. Next up are the comparison operators. The idea here is that often in your code, you need to test for a condition. If the condition is true, some code should run. If the condition is not true or false, then maybe some other code should run. The condition you're testing for will often involve comparing one value to another. For example, you may want to display a message to the user if the quantity entered is 0, or if the email text box is empty, or whatever you need to check for. For these kinds of expressions, you can use comparison operators. And these compare two different values. First is the equality operator, which is two equal signs. Now make sure you don't confuse this with a single equal sign, which is the assignment operator. Two entirely different functions. So the equality operator returns true if two values are equal. Bang equal or not equal returns true if two values are not equal. Greater than returns true if the first value is greater than the second. Less than returns true if the first value is less than the second. Greater than or equal returns true if the first value is greater than or equal to the second. And less than or equal returns true if the first value is less than or equal to the second. So very simple and straightforward kind of logical operations. And here's some code that shows how to use the operators. So I'm starting by declaring a couple of numbers, 100 and 200, and I display them at the top. Number 1 equals whatever, number 2 equals whatever. All right, so here I'm comparing number 1 equal number 2. The result of this expression is a Boolean value, so it's either true or false. And in this case, it's going to be false because 100 does not equal 200. This is going to return true or false if the numbers don't equal each other. So this is going to return true because they are not equal to each other. And also, in this next example, I'm not limited to comparing just the values of variables. I can compare the values of expressions. So the value of this expression on the left is number 1 plus 200. 200 plus 200 is 400. And is that greater than 200? I'm sorry, 100. 100 plus 200. That is, in fact, greater than 200. So this is going to return true. Number is number 1, which is 100, less than number 2 minus 100. Number 2 minus 100 is 100. Those are equal, so it's not less than. So this is going to return false. And then check to see if it's greater than or equal to and less than or equal to. So I can run this code and execute J. And you can see that number equal number 2, false. Not equal to, true. Number 1 plus 200 greater than number 2. So again, this is 100 plus 200, that's 300. That is in fact greater than number 2. Is it less than number 2 minus 100? False, because they're equal. Again, that's number 1 is equal to the value of this expression. And is number 1 greater than or equal to number 2? No, it's not. It's 100. Number 1 less than or equal to number 2. And that's true. So this is very simple and straightforward. But you can also get much more complex in your comparison expressions.